I don't. If somebody is removed, please rejoin. I don't know what happened, but Neha Chaudhary was removed from the meeting. Ask her to join. I don't know what the problem is exactly. She may join once again. Rohit Brahmankar has left the meeting. Any problem? I don't know. Have I dropped the message on both the groups? Because only 56 students are there, not the number that is desired at this point of time, 58. So let me check whether I have, yes, I have dropped the message, make B and make A. Because see, the first point will be contents beyond syllabus. Then the second point is the way in which the submissions are to be prepared, that is, the journal is to be prepared, and the methodology for online submission that we shall discuss. And third one, very important, that is actually a sort of assignment because we have MCQ test, online test on first 3 units few months back. Now we have got remaining 3 units, unit number 4, 5, 6. So a sort of assignment, I won't call that MCQ test, but a sort of assignment based on unit number 4, 5, 6 that we have to do today, and marks are there for this assignment, isn't it? That's why I want everybody to attend the lecture. That's why I made an appeal to all of you to attend the session. The second point will be MCQ. Assignment in the form of MCQ. But since this is assignment, I will be helping you because I know that you are all are busy in the submissions and you don't have much time to study the theory part. That's why what I will do, I will help you in completing the assignment. That is MCQ, but I will be rendering help to you. And marks are there, isn't it? And those marks will be counted at some stage. So please ask all to join. 66 have joined. I don't want anybody to lose the marks. That is important, isn't it? So remaining absent for one of the lectures due to some problem, I can understand. But losing marks, I don't want this to happen. That's why please ask to join. The third point, see, first point is contents beyond syllabus. Second point is assignment. I will be helping you out in that completion of the assignment. The third point, let me check. I have made a list of things to be covered today. So, yes, of course, the first point is content beyond syllabus. Second point is submission, that is lab manual. Third point is assignment, MCQ. Fourth point is course and survey that we have to complete. And the last point is very important, that is today's attendance. Okay, so in these 2 lectures, we have all these points on our agenda. Okay, so let me share my screen. Deliberately, I have kept the third point as MCQ assignment so that more and more people will join, isn't it? So it's just 10 past 11 or 7 past 11. So we shall wait for people to join for that assignment, MCQ assignment. So that will be third in a row. First will be content beyond syllabus. Let me share my screen. We shall discuss the worm gearbox. Why we are discussing that I will let you know because it has got some relevance with the syllabus. What I want to share is, yes, content beyond syllabus. Just let me know whether you are able to see my screen, that is Word file of contents beyond syllabus. Somebody please speak up.
Yes, sir.
Yes, sir, it's visible.
Yes. Okay. Is my voice okay?
Yes, sir.
It is sufficient, no? You are able to hear me?
Yes, sir.
Yes, very good. Now see, the basic objective of theory of machines 2 is to learn kinematics of the gears. By kinematics, we mean motion of the elements. Dynamics is different, kinematics is different. Theory of machines 2 means kinematics, and in final year, you will be having one subject called as dynamics of machinery. So currently, your B students, your seniors are learning dynamics of machinery. Right now, we are discussing kinematics, means motion of existing machine elements. So what we are doing is we are trying to learn existing machine elements or existing gearbox, means the gear, like a spur gear or helical gear or bevel gear, or you may call any of the gears. What we are doing is we are trying to learn existing gear, the tooth form, how it looks like, the working profile, different terms associated with the gear, pressure angle, and so on. What are the available tooth forms? See, whatever we are discussing, that is important from oral viewpoint also. Because if you ask me a list of questions, that is highly impossible for me to give it to you. But yes, while discussing itself the syllabus, you may make a list of the questions. I'm not of the opinion that make a list of questions and give it to you. Not possible. I will prefer to discuss with you the contents of the syllabus, and while doing that, you may catch the questions and remember the questions. That's what we can do. So whatever we are discussing, that is important for from oral viewpoint. So if the examiner asks you the meaning of kinematics, then you have to say that kinematics of gears, like it is all about studying existing gear, which includes different terms of gear, then phenomena happening, that is interference, undercutting, deciding number of teeth, the available tooth forms, that is 20-degree pressure angle, 14.5, 22.5, and so on. So in term 2, we are learning the different terms associated with the gears. So we are also carrying out the force analysis. So what I mean to say is, at the end of the syllabus, like this is supposed to be 68th lecture, 60वा lecture है आपले हे. So at the end of the syllabus, what you can do is you can proceed for designing the gears or gearbox, because you are now aware of the existing gears, different types of gears. You also know that a single pair of gear, spur gear, can be used for achieving a reduction ratio of 6. If you want to reduce the speed by a factor of 10, then single stage can't be used, or two stages to be used. We also know that if reduction ratio in the range of 40 or 50 is needed, then ultimately a worm gearbox is to be used. So these things are known to us. So with this knowledge with us, if somebody asks you to design a gearbox, say for a conveyor, or a machine tool like lathe machine, or if your task is to design a gearbox for college lift, then that can be undertaken. If this task was given to you somewhere in the month of May or June 2020, you wouldn't have undertaken, because you are not having the knowledge of kinematics or Form 2. So at the end of the syllabus, you can proceed for designing of the gears. You will assume appropriate mode of failure. See, whenever a machine component is to be designed, you have to consider probable modes of failure. The modes of failure is to be predicted by the designer based on the way in which force acts. If the force acts in a transverse direction, that will cause bending of the machine element. Accordingly, what you will do? You will form the basis of mode of failure, and you will say that mathematically I can apply the equation, that is Flexner formula, sigma upon y equal to m upon I can be applied. Based on this equation, you can find out the dimensions, because design of machine elements is all about designing the component, deciding the shape and size. So finding out shape means how it looks like, and finding out the dimensions, that is size of the component, is the net outcome of any design. But while doing so, in between steps are there, like you have to assume appropriate material. List is huge, like you may assume the material as cast iron or some grade of steel like alloy steel or plain carbon steel or mild steel. Again, you may go for appropriate heat treatment like carburizing and so on. Because ultimately for some of the components, we want our surface to be hard and core is to be soft. Accordingly, appropriate heat treatment is to be thought of. So when you go to the industry like machine tool industry, they have got their own metallurgy department wherein the heat treatment will be done for the components. So ultimately, a design engineer, you will be design engineer at the end of the say your course or your entire engineering. So as a design engineer, you have to give consideration to many things, isn't it? So many viewpoints are there. What material should I select? What should be the heat treatment? It all depends on the loading conditions. Whether the loading conditions are like static or dynamic, that also to be considered. That is to be considered. Remember that gear and bearing are the machine elements which are subjected to fatigue loading, because loading cycles are going to be repeated. That's why it is not a case of static loading. Like you have considered a beam in your SOM lab on universal testing machine and applied the loading. So you assume that the load is static in that case. When you draw SFD and BMD in SOM, you assume that the load is static. But remember that for majority of the machine elements, the load is not static, it is dynamic in nature, isn't it? Fatigue loading is there, repetitive loading is there. So all these considerations must be given due importance by design engineer. Then mode of failure is to be assumed, then loading condition is to be thought of carefully. Intensity of load is also to be thought of. Like from the design calculations, you may get one of the loads as 1250 Newton. But remember that there may be rise in the loading, isn't it? There may be rise in the loading due to dynamic effect. So the load is to be increased, because if you assume 1250 as the load on machine element and design the element, then ultimately the element which is designed may not be safe, because for a fraction of second there may be rise in the intensity of load that may cause failure. So ultimately factor of safety or different factors comes into picture. We shall discuss more on this during DME2 in the next term. We have got design of machine elements 2. In the next term, we shall discuss in full depth about all these aspects. Today, my attempt is to give some idea about what we are going to do in DME2, because this is supposed to be transition phase for you people. You have learned TOM2, now you will be jumping into DME2 a few months, in a time of few months or few weeks, I must say. So this is a sort of transition, and the transition should be smooth, because at the end of the syllabus, you must revise what you have learned, and before you start DME2, you must be having feel of what is to be done. So what you have learned in term 2 and what is to be done in DME 2, that I am trying to explain to you today. I just want to throw a light on that because this is very important. So let's assume that you have to design a gearbox, isn't it? So ultimately, while designing a gearbox, as a designer, you will choose either a single stage or two stage or a worm gearbox or a bevel gearbox and so on. Because it all depends on the reduction ratio to be achieved. It all depends on layout of the shafts. Whether input output shafts are parallel or at 90-degree, that governs the gearbox. That is kind of gearbox, isn't it? So we have got many lifts in the college. So I have visited the lift room of the college, and the type of gearbox they have used is a worm gearbox, isn't it? So what we have to do is we have to think of, see, while designing a gearbox, you must select the motor because nobody will give you idea about the type of motor to be selected. You are designer means you will be doing everything. You have to choose material, you have to select motor, you have to go to the market and look for the available motors. Everything is to be done by you. You can't say that A will choose the material, B will choose the motor, not like that. Bearings are to be selected. You yourself will do the selection of all machine elements because that is your project. Because when you go to industry, let's say that you are given the role of design engineer, then you must know all these things. You have to refer the standards followed in that company. But standards may be different, but the theory remains same. One who has got sound knowledge of theory, he or she will be the most successful person while working on real life projects, that is in industry, isn't it? So while working on real life problems, no doubt the theory which is learned during the 4 years will help you definitely. Because I have worked in industry. I was design engineer in CNC machines, gearbox. They were manufacturing gearbox and special purpose machine. They people also refer the design book. They also refer the standards. They also need the theoretical aspects. Not that they will design the system keeping aside the books, keeping aside the course analysis, keeping aside the standards for material, all that. Whatever we are learning, everything will be needed while designing a real system. So again, I repeat, a sound theory is needed while working in industry. Theory must be very, very sound. You may forget, and obviously there is possibility of forgetting some formulae or equations. That is okay, accepted. You can refer books for that. You can refer books, standards, and recall the formulae. But understanding of the theory and mathematical background is very, very important. Just remember these my words. You will definitely remember me when you work in industry at the end of the your course, that is engineering. So let's try to understand a worm gearbox. Okay. So what we are trying to do is we are trying to take overview of worm gearbox for college lift. We are just making a list of design considerations. We will be going through the drawing of the worm gearbox, that is assembly as well as details. If you were in this lab, then ultimately we would have dismantled the gearbox. We would have touched each element. We would have carried out the assembly, but it's not possible due to online mode. But I will show you the gearbox in the assembled state and dismantled state. This much can be done definitely. Okay. So this is a gearbox. This is a gearbox, worm gearbox. Right now, you are able to see the casing of the gearbox. This is called as casing of the gearbox. And this one you are able to see a shaft in the plane of the computer. So remember that worm is driver, wheel is driven. So this is supposed to be the driving shaft. Somewhere here, motor is coupled to this gearbox. Okay, you are able to see these bolts. With the help of the 4 bolts, the bearing cover, this is called as cover of the bearing. Inside the cover is actually a bearing. So front bearing and rear bearing for the wheel, and this is the bearing cover for the worm. So 2 bearings for the driver, that is worm, 2 bearings for the driven. Now see, ultimately worm is smaller in diameter, wheel is larger. So large bearing cover gives you idea of the wheel which is present inside this portion. Now people normally make use of a split casing, but this is a one piece casing that we shall see. Okay. Now you are able to see the projected part like this for projections. You know, you are expert in heat transfer now. So these are actually fins, FINS, fins for dissipating the heat which is generated in the gearbox. Remember that efficiency of the worm gearbox is very low because of high friction, because you might be knowing that high sliding is there. In this case, in case of worm gearbox, greater friction is there, sliding friction is there. That's why heat is generated, that is to be dissipated. So with the help of the fins, the heat is to be dissipated. Okay. Now, I have already dismantled the gearbox for you. So different parts of the gearbox are this one. This one is actually worm, which is driving member, isn't it? So remember that as far as worm is concerned, worm and the shaft are integral. In case of worm, that itself is shaft. So on that shaft, 2 bearings are mounted. Now again, selection of bearing and design guidelines for bearing, that will be covered in DME 2, design of machine elements 2. So different, let me enlarge this because you might be using your mobile phone. That's why it may not be visible to properly. Now see, you're able to see the worm and the bearings. So again, which bearing is to be selected? Like which gearbox is to be used? Similarly, which bearing is to be used to support the shaft? Every selection is to be justified by calculations. Not that randomly X bearing is to be used or Y bearing is to be used. We are engineers, we are physicists. We will always support our selection or judgment backed by calculations. Application of science is engineering, and application of engineering principles gives birth to a product which is engineered. So remember that all these components are engineered components, isn't it? So while selecting this bearing or that bearing, some calculations are needed, isn't it? If you ask me different types of bearing, then we have got deep groove ball bearing, then we have got roller bearing, taper roller bearing, we have got angular contact bearing, then we have got needle roller bearing, taper roller bearing, cylindrical roller bearing. List is huge. Probably Baha and Supra students might be having greater knowledge of this thing. Now see, few bearings are capable of taking radial load only, and there is other class which will take radial as well as axial load. Because again, while selecting any component or while designing any component, the loading pattern comes into picture. Intensity of load, direction of load, and the nature of the load. Direction is all about whether it is radial, tangential, or axial. Intensity is all about magnitude. And during operation of the machine element, whether the magnitude of the load remains constant or it varies, that is very important, because see, the calculations will give you one fixed value of the load. The calculations will give you one value of load. For example, knowing speed and RPM and diameter of the pinion, you can find out the tangential load. The calculations will give you only one value, like tangential load is 1500 Newton. Radial load is say 1000 Newton, axial load is 800 Newton. That is single value. But a designer must predict whether there is possibility of increase in this load due to some reasons. For example, mostly the prime mover used for the systems are either a motor, electric motor, or in some cases IC engines are also used. So if there is variation in the torque supplied by the motor, then ultimately there is possibility of this loading to vary. We know that in case of IC engine, torque developed itself varies. Like we have got suction stroke, compression stroke, expansion stroke, and exhaust stroke. We have studied torque theta diagram. We know that torque is maximum at the power stroke and it varies from cycle to cycle, that is suction to compression to expansion to exhaust. It does mean that the first variation occurs at the source of power itself. The second variation occurs at the power transmitting elements, like you have got meshing between pinion and wheel. So the meshing action may itself cause change in load. That's why whatever you have calculated as tangential, radial, axial, that is subjected to change. You can't assume these calculated values at the fixed values. You have to increase the load due to possible variation at the source, possible variation at the power transmitting elements, and blah blah blah. That is all about intensity. And the third aspect of the loading is the loading pattern. Whether the load is static, dynamic, if dynamic, whether it is repetitive or whether it is cyclic, and so on. All these factors play important role, based on which elements are to be selected. Likewise, if we have got helical gear, then we have got additional third axial load. Accordingly, the bearing must be capable of withstanding axial load. So the bearings that can withstand radial as well as axial load are deep groove ball bearing. A cylindrical roller bearing will support radial load, it will not support axial load. Angular contact bearing supports both radial and axial load. Taper roller bearing supports radial as well as axial load. Accordingly, the bearings are to be selected. Excuse me. Now, in case of worm gearbox or worm, we know that axial force is there in addition to radial and tangential. That's why you're able to see the taper roller bearings, isn't it? This is all about the worm. Then these are the seals in between the bearing cover and bearing, so that no foreign particle will enter the bearing. Let me zoom out. Now see, this is actually bearing cover for this wheel side. This is bearing cover for driving side, that is worm. Okay. Now see, more important is wheel. You are able to see the shaft of the wheel. In case of worm, shaft and worm are integral. In case of wheel, you have got separate shaft on which wheel is mounted. Now remember that in case of wheel, it is made in two pieces. You have got a central cast iron hub on which a rim made of phosphor bronze is mounted. You have got a central cast iron hub on which the phosphor bronze rim is mounted. And then you have got the bearings. These are the elements. And then we have got this casing of the gearbox. This is a single piece casing. You may make use of a split casing, that is upper hall, lower hall. But in this case, what is done is opening of the gearbox on the wheel side is slightly greater than diameter of the wheel, isn't it? So how to dismantle this? Take out the bearing covers from driver and driven. So this is now opening, isn't it? You can take out the worm. Deliberately, the opening on the wheel side is large so that the large diameter, large size wheel can be taken out. Due to this large opening, we are able to use a single piece casing, isn't it? Now, this is actually AutoCAD drawing. Last year students, last year means those who are in now final year, they have drawn detail and assembly. I should not explain to you the basic reason for drawing, so to say, details and assembly. Details we draw so that the components can be fabricated. But remember that when you draw detailed drawing, each dimension should be specified. If a single dimension is not specified, then ultimately the person on the shop floor will not be able to carry out the fabrication. Each minute detail should be mentioned in the drawing. Assembly drawing is meant for making assembly of the components once they are fabricated, isn't it? See, the thing is that when you go to industry and you are given the task of design engineer, there will be people supporting you, working under you, and those are ITI draftsmen. Now see, remember that the ITI draftsmen are very expert in reading the drawing and drafting in AutoCAD. Because an engineering student will learn theory, many subjects, probably 10 into 440 subjects. He will learn many softwares like CFD and ANSYS, SolidWorks, AutoCAD, and so on. You can think of carrying out vibration analysis, trace analysis. So you learn many things, but ITI draftsman, the role is limited. It is all about reading the drawing and drafting in AutoCAD. So they have got good experience of reading and drawing. So they may be ahead of we people when it comes to reading the drawing and drafting the things. So we have to remember that when you work in industry. You must be also be equal expert so that you can work as a leader. A leader is supposed to know all the things. He must have 360-degree feel of the things which are taking place. Because ultimately he will be the boss. You will be giving the guidelines to your subordinates. And you will do that provided you know each and everything in detail. Otherwise, there will be big problem. So, coming back to this assembly, two views are drawn. Again, the lower side is worm side, upper side is wheel, there is front view, and this is side view. Now, this is the driver or worm. The keyway provided here indicates that somewhere here motor will be coupled, isn't it? And since the shaft angle is 90-degree, the other view will describe the output shaft. This is output shaft. Now see, as I said, you have got a rim which is fixed onto the central hub. This is a rim, phosphor bronze rim, bolted to the central hub. Then you have a keyed shaft, output shaft. So somewhere here application will be mounted. And then finally a bill of material is to be prepared, like casing, worm shaft, worm wheel, bearing cap, I lost my connection. Wait. I lost my connection in between. I hope you all are back and you are able to see this. I lost my connection. But I said yes. In the first practical itself, I asked my students to occupy the lift at the ground floor and travel to fourth floor. So we assume that force is meant to 60 feet. So that is supposed to be linear speed of the lift. Gearbox, a pulley will be there on which we have got a rope, and that rope carries the cabin of the lift or lift. So we have got the change in motion, that is using the rope and the pulley. The linear motion is converted to rotary motion, or in fact, I should say in other way. We have got rotary motion available at the output of the gearbox, that is changed to linear motion. So linear speed is known. Then we have got some pulley. I don't continue beyond this level, that is lift one gearbox. Overview of the gearbox is over. If any doubt is there, please revert back. I will wait for 2 minutes. So today's first task is over, that is contained beyond the syllabus. So let me close this. This matter is discussed. Now, when you refer the syllabus of each subject, some statements are mentioned in the syllabus. Those are called as course outcome statements, CO statements. So remember that here course stands for a subject. Outcome is outcome. What is outcome? Outcome is like what you have gained, that is the outcome. Outcome of examination will be how much marks you gained at the end of the exam. Outcome of engineering can be measured in terms of the employment that you get, in terms of the package that you will get, in terms of how good you as an entrepreneur would be, how good your business will run. That is outcome of engineering. Or the university that you will be admitted for your higher education, that is outcome of engineering education, isn't it? Similarly, course outcome stands for the knowledge or the extent of knowledge that you have gained at the end of the course. That is, term to course outcome means the extent of knowledge, the things that you have learned at the end of the syllabus. And for me, mostly 90% of the syllabus is over. If we keep aside few theory like gearbox and all that, For me, 90% of the syllabus is over. So at the end of the syllabus, the knowledge that you gain, that stands for course outcomes. Now remember that we have got 6 units. So we have got 6 course outcome statements. So unit 1, that will be CO1, unit 2 CO2, and so on. So let me share with you that course outcome statements. Wait, window. Yes. Are you able to see my screen? Word file? Yes, now. Now see, these are the, let me make it bold so that that will be clearly visible to you. So these are the course outcome statements for theory of machines 2. See, the thing is that we are following outcome based education. Nowadays, since many years, we are following outcome based education. So accordingly, what should be the outcome at the end of first unit, that is described by CO1. So what is CO1 statement? You will be able to apply fundamentals of gear theory for gear design. And just now we have discussed that. Fundamentals of gear that you have learned can be applied for designing a gearbox for a worm or a machine tool or any application conveyor. Okay. Unit 2 was based on helical, bevel, and worm. Accordingly, second statement is ability to perform force analysis of spur. Yes, you can do it. Force analysis of helical, bevel you have to learn probably. Worm we have done. Third unit. Yes, you are able to now analyze speed and torque in epicyclic gear train. We have gone through many numericals and we had one experiment based on this, isn't it? Unit number 4. Yes, you are able to design cam profile for given follower motions and understand cam jump phenomena and so on. You are able to synthesize a 4-bar mechanism. Many of you might have drawn the drawing sheets. So that's all. Finally, you are able to analyze gyroscopic couple or effector for stabilization of ship, aeroplane, and so on. And you are able to choose appropriate drive for given application. These are the statements. Now, these are the statements, but see, the outcomes should be measured. That is important. Simply showing you the statements will be half the task. So what I will be doing is, I will be much preferring to know from you how much you understood unit number 1, unit number 2, and so on. That feedback I'm going to take today, right now. Now you have to be very honest. Just, I am asking you the extent to which the knowledge you have gained. Don't say like, I have understood to the fullest extent. The case may be different from person to person. That may vary. That is going to vary. Now you can say that now I have understood 50% of first unit, 60% of second unit, and cam profiles 100%. That is left to you. So be honest. Whatever you have understood, based on that you have to give the feedback. Nothing is compulsory. Not that like in the form 3 is the highest rating. 3 means yes, understood fully. 1 means lesser understanding is there, and 2 is moderate. So nobody is going to check what X has done, what B has done, what C has done. You have to do it. That's all, nothing else. Okay. So let me share that form in the chat box. You have to do it right now. I will give you 5 to 10 minutes and you will be submitting today itself during the lecture. But once again I say, you have to be very honest. Whatever you have learned, accordingly, please give the feedback. So, should I explain you the form first? I think the form is to be explained and then you fill it. Let me share my screen once again. Where is that? As I said, we have to do 3, 4 activities. Present now, tab. I have shared, it will be visible to you shortly. Are you able to see the form? Please reply.
Yes, sir.
Yes, no?
Yes, sir.
Yes, you're able to see the form?
Yes, sir.
Yes, very good. What is written? What is highlighted? Please tell me.
PVG's College of Engineering.
Yeah, we are PVGNs, right? Now see, this is for 2021 term 1. Dear students, please take time to complete this survey. Your thoughtful and objective responses to each question are highly valued part of teaching learning improvement process. Please use the following scale to answer the question statement. 3 strongly agree, 2 agree, 1 neutral. You have to write your email address, your name, your roll number, your division. See, the first question is I means you. You are able to apply fundamentals of gear theory. So it varies from person to person. You may say 1, 2, or 3 as the case may be. Similarly, second one, again rating is there. You have to click appropriate answer. So let me share the form to you. I will drop the form in the chat box. You have to complete within 5 minutes because we have many more things to do today. So refer your chat box. I have dropped the form and complete this survey right now. Link is there. Please do this. Don't leave at the end of the form. This is not attendance link. This is Google form for course and survey. Many more things are to be done. We have got 2 lectures today. Okay. So please take 5 minutes. Be calm. Just relax. No hurry. Take your time. कुठल्याही प्रकारची गडबड नाही आपल्याला. Sorry. So I'm back. Have you submitted? All of you? Let me check.
Yes,
Yes,
sir.
Submitted.
Yes, sir.
Okay, I will check how many have submitted. Let me go to Drive. 80 have submitted, 80. Number of students are 93. Only 80 have responded. So those who are remaining, please submit at the earliest. 81, the count is going up, but not the speed. Please decide 82, yes. Remaining 11 also, please do it. Okay. So let me close this. Now the third point in the lecture is the manner in which submission is to be prepared, that is, file is to be prepared and to be uploaded by you people, that we are going to discuss. So let me share one sample file. Just wait. I'm doing it. Wait. Just wait. I'm doing it for you. Open. Let me share. Share means share my screen. Present now. Could I IT file present window? Now share. It will take some time. Are you able to see the PDF that I have shared? Are you able to see?
yes, sir.
Yes. Now see, I have shared you few days back the PDF for 6 experiments. Those were the write-up. Okay. And what you have to do is, in that write-up, you have to write your name. Okay. So online you can do it. Okay. Because if you write by a pen, then ultimately for doing that, you have to take printout and then you have to write. Okay. And what you can do is, don't take printout, just use the tool and do it online, isn't it? So like, you have to write your name, roll number, class, let it be mechanical batch, and division A, because you may not be knowing T1 or T2 or T3 what it is. So mechanical is okay. So just make sure that this is done with this font. Don't make it small. This font is okay. This color is also okay. Okay. This is as it is. Nothing is to be done. Now, this is also to be filled. Now, what I have done, you remember. Dates I have already written. So on this page, you have to write the page numbers. And you know the page number, what it is. Only thing is that 1 to 6 we have got write up. Okay, so accordingly, numbers are already put there. 7, 8, 9 are the sheets: conjugate, cam profile, and synthesis. Okay, so do one thing, like you have got up to 6 the write-up given to you, that is PDF copy. What you have to do, 7, 8, 9, these 3 sheets, once you draw, scan as a single PDF. I repeat, sheet number 7, sheet number 8, sheet number 9, once you draw it, scan as a single PDF. Now you have got 6 write-up as one PDF, 3 sheets as a second PDF. You have to merge these two. Okay. Now put page numbers on the drawing sheet also, accordingly transfer those numbers here. Okay. So this is to be done. Once you do this, then you have got either 51 or 52, whatever is the size, total pages. Nothing is to be done for 1 to 6. Already everything is there, isn't it? This is already done. This is with you. Number 2, it is already there. Everything is there, along with the calculations, along with the table, along with the outcome, output. This is already with you. Nothing is to be done, my dear friends. Number 3, everything is there. You have got this observation, sample calculation. Remember that these are all our readings. We have taken this year. Just remember this 1066. This was the theoretical RPM. How? What we did? We have the observations. DC motor 0.5 HP. Stiffness of the spring was 892. Free length was 106. Mass of follower is 0.354. Eccentricity 2 millimeter. And we have got this formula for the jump speed. Based on this, remember that for 2 millimeter deflection, theoretical speed was 1066 RPM. Just keep in mind, the first RPM that is going to be useful. 1066 is the jump speed. Don't forget this. Accordingly, calculations are shown. This you can read afterwards. Okay. What is the jump speed? 1066 RPM for 2 millimeter deflection. Then gyroscope. Again, everything is there. One should not worry about Tom to submission. I have to write this, I have to write that, because I also understand that you have got 5 subjects, you have got heavy submissions, you have got lesser time, you do not meet with your friends, everything is online. But not to worry about Tom 2, everything is there. You have to devote a lot of time for study. You have to study this, that is more important. Writing is not important. understanding these signs, remembering is more important. That's why everything is there. Okay. Then you have this result. If these gearboxes study experiment, it is left to you. You can understand this. There should not be any problem in this. And this is CBT. Yes, nowadays we make use of CBT. Just read out this. All is theory. Now, 44 pages are with you as a single PDF. The second PDF, you will scan these 3 sheets. Don't forget to write conjugate as 7th experiment. Title is to be written. This is to be done online. Means once you merge these 2 PDF, then you will be having this as blank. The top will be blank. You will be having the sheet. Above that, write experiment number 7, title of the experiment as per the syllabus or as per the first index that you have already. This is very important. Huh? This is very important. You must write this. And write this also, your name and what to say, number and division, conjugate. Then you have got CAM profiles. Again, you have to write this online using some tool over here. Experiment number 8, title as per the syllabus. And experiment number 9, title of the experiment and this thing. That will be end of the file. Any problem in this, like you have got the synthesis for 4 bar and the crank slider. Any problem with this? I hope you have got the Word files with you for synthesis. Anybody has got some problem in this experiment, synthesis of mechanisms, please revert back. This is the best platform we can discuss about it. Try to discuss later. We can discuss it right now. This is very simple. It will take hardly 10 or 15 minutes. Now, this is all about 51 or 50 pages, whatever will be the case. Now, this is to be renamed as like. What you will do, you will write this as, let's say that my number, roll number is 1, 2, 3, 4. 1, 2, 3, 4 is your roll number, followed by your name, followed by PE, make either A or B underscore Tom2. Are you getting my point? You have to, let me stop sharing. You have to rename this file as mentioned in the chat box. Please refer the chat box. Your roll number, like 1, 2, 3, 4, your name Praveen Kulkarni, your class and division, and Tom2. I think I have made everything clear to you. Once you do this, you will be having one PDF ready for submission. Now, I want to discuss with you, number 1, deadline for this. When will you submit this? How to submit, that is second part. What should be the deadline? Please type in the chat box or unmute yourself and tell me the deadline. Today is 2nd December. How many days do you need? Otherwise, if you don't revert back, I will mention one date and time. By that time, you have to upload. Right, 12. Let me see the calendar. Anybody else? See, tomorrow between 10 to 12, okay. Anybody else? Because see, ultimately you have got 6 ready experiments. It's a matter of drawing 3 sheets out of 3. Conjugate might out of 3 drawing sheets. I think already conjugate has been drawn. Cam profile has already been drawn. Your pending task may be the 3rd sheet. So thanks for responding. I think since first PDF is already with you, it's matter of 3 drawing sheets. What I will do is, I will type the deadline for term submission as, keeping in mind that you have got many submissions to be done in this week. What I can do is, I can give you the deadline as Sunday, 6th December by 5 p.m. So today's 2nd, 3, 4, 5, 4 days are more than sufficient. Because let's say that somebody has not drawn the sheets. Conjugate can be drawn within half hour, cam profiles half hour, because only 2 problems are there. Originally 4 problems are there, because of online mode, I have reduced it to 2 only. So 1 conjugate, 2 cam and 2 synthesis. It will not take, my dear friends, more than 4 hours. So I think, Sunday, I did not mention the date. My God, Sunday. Let me write the date. 6th December. Huh? Sunday is 6th. So I think 6th December is okay, isn't it? So make sure that by Sunday, 6th December, by 5 p.m., you will upload. Now the second point is, before that, make sure that you save your file in this format only. This is very important. Huh? Once again, I repeat. This is very important. You must write your roll number. That PDF has to be saved as number, followed by name, followed by class, followed by division, lastly term 2. Now, I have not finalized the mode of submission. You just prepare your PDF, and within 2 days, I'll let you know whether it will be like Google Classroom or Google Form will be there, or what it will be. I will be, Advait Kulkarni. Advait, Vaishnav. So the way in which it will be accepted, let's decide within 2 days. Make sure that you complete this activity first. You make your PDF ready and wait. And by tomorrow, I will explain, let you know the mode in which the submissions are to be uploaded. Okay. So this was the third thing. First was contents beyond syllabus, it is home gearbox. Second was course and survey. Third is this submission. 2 things are remaining. Last thing will be attendance, and the next thing will be assignment. That is in the form of MCQ. And don't worry, I know you don't have much time to study nowadays because of submission week, but I'm going to help you in the assignment. Okay. So let me, the chat box. Isn't it important for the heading and the title of the experiment for the sheets to be in the same format? Isn't it important for the heading? Himanshu, what do you exactly mean to say? Unmute yourself.
Sir, I mean to say that the experiment number and the title of experiment that you
Repeat now. No, you're not audible properly. Yes, what is your query? Elaborate on this. Himanshu, what's your query?
Sir, am I audible?
Yes, yes.
Sir, I mean to say that the experiment number heading and the title of experiment that Shubham has written in his PDF
Hmm.
has to be bold and underlined like the previous experiments that you have sent us, because it is looking somewhat awkward in the simple font. I mean to say for the elegance purpose.
For the which purpose?
For better view purpose, because it is looking awkward.
No, no, that will be okay. You just follow any
Others
font.
are in the same format and suddenly.
No, no, it will be okay. It will be okay. You follow any font, I mean, not font, any type. Font size will be 14 invariably. And that will be uppercase. But the type of font, if possible, then make it Times New Roman. Otherwise, whatever way you want. It will not be carrying much weightage. Only I want experiment number 7, 8, 9. Experiment number 7, title, and then your drawing sheet corresponding. 8, title sheet. 9, title sheet. That's why deliberately I gave you the PDF for only first 6. Initially, I gave you for 1 to 6, and then I wrote experiment number 7 blank page, 8 blank page, 9 blank page. 2 days back, I have given you only 6 experiments PDF, so that you can add the merge the second PDF and accordingly write the title and experiment. Okay, I think things are clear to you. Now, as far as the assignment is concerned, I will be giving you some time for completing the assignment. Okay, so let me drop the link. Once again, as I repeat that I know that you didn't get much time to study, but still try to attempt that. I will be helping you because this is assignment. This is not a test. Means ultimately you can refer the books for completing this. So don't be panic. You just try on your own. I will be giving you 15 minutes, 5 minutes. Don't submit. We will discuss it and then you submit finally. Okay, so the assignment is totally based on 3 lectures conducted on synthesis, then gyroscope and cam jump phenomena. So few questions you are in a position to attempt, few you may not, but don't submit. We shall discuss and then you have to submit. Okay. Refer the chat box. Okay. Try to complete this. 15 minutes are given to you. At the end of 15 minutes, we shall discuss, then you submit, please. Okay. Any doubt, please refer chat box.